Hello, this is Mr. Rasmussen with Algebra 1, Lesson 84. It says two parts, and the first part is on the multiplication of radicals. And so we see these square roots in here, which are the radicals, and we've got two terms, and we want to multiply them together. Now, the way we do this is we have the first part and then the second part in the square root. We can multiply the first parts, so 4 times 3, which is 12, and then we can multiply the second parts, or if we write it out as this, right, is the same thing as 12 to the square root of 6, we can multiply the second parts. And it's as simple as that to simplify that particular problem. All right, let's look at example point 3. Here, we want to remove our parentheses, so that means we're going to multiply the first part into both of those. So once again, the 4 and the first part here, the 5, get multiplied to be 20. And then the inside get multiplied, and we get the square root of 6. And then plus, and then here, 4 times 6 is 24. And we multiply the inside there, square root of 9. However, the square root of 9 is 3. So 3 goes there, but they're still connected by multiplication. So 3 times 24 is 72. So we can rewrite our answer as 20 square root of 6 plus 72. All right. Look at the other examples if you need a little bit more help on that. But basically, the first parts get multiplied together, and then the second parts get multiplied together. The second part of today's lesson involves functions. This might look a little complicated, but it is really quite simple. You have an input. Remember, we described a function like a machine where for every one input you get one output. Now, the first thing is when you put an input in, you can't get two outputs for one input. So for example, if we have a 4 as an input, we can't have both 3 and 2 be both the answer. This is not a function. However, if we have 4 as an input and that one gives you an answer of 2 as an output, you can also have 3 as an input give you the same answer of 2 as an output. You can have the same output for two different inputs. Okay, so if you look through those, that's the function for it to be a correct function, it needs to follow that. If it isn't, then it's not a relation. It doesn't work. Okay, they also give this to you in the form of coordinates. Now notice the inputs are listed as domains and the output as ranges. That's the same as our previous lesson where the inputs was the x value and the output was the y value. So in this case, when we list a set of coordinates, if we have 4, 3, the 4 is the x value and the 3 is the y value. Therefore, it makes the 4 the input and 3 the output. So if we look at all the inputs, and let's see, if I put here, I go 9, 3, I think they also have 5, 7. If I look at all the first numbers and they're all different, then that's a function. However, if I look at an input and 2 of them have the same input, okay, as long as they have the same output, it's still a function. However, if I were to have 4, 4, then I have the same input and a different output, a different range, that negates it as a function. It is not a relation. Okay, you can look through the rest of the examples there on the next page and see how that plays out. I'm going to move on to the practice problems, so feel free to pause the video and answer those yourself for work, and then check your work and answers with mine. All right, so practice A, once again, gives us our two terms there and has us multiply them. 4 times 5 gives me 20. 12 times 3 gives me 36. However, the square root of 36 is 6. So 6 times 20, I get an answer of 120 for practice problem A. Practice problem B, I'm going to multiply my first part into both of these to remove my parentheses. So 3 times 4 is 12. 2 times 3 is square root of 6. plus 3 times 5 is 15. 2 times 6, square root of, not 16, square root of 12. And that is, well, I can ask myself, in this 12, can I reduce that at all? Now, it's not going to go away, but the square root of 12 is the same as 3 times 2 times 2. And so these two 2's can come out. Henceforth, I'd have 15 times 2. So my answer, 12 square root of 6 plus 15 times 2 is 30, with a leftover square root of 3 there as my answer to practice problem B. All right, in practice problem C, it asked me whether this is a function or not. Let's see here. A gives me one answer of 5, 6 gives me one answer of 11, 7 gives me one answer of 11. This is a function. Answer is yes. Look at practice D. Is this one a function? I have one input here, gives me one output. Here I have one input, and it can't give me an output of both A and 7. That can't, one input can't give me two outputs. This is not a function. Does not work. Okay, practice problem E asks me, what is the domain for problem C? Well, if you remember, the domain is all of the first parts, and the range is all of the second parts. So simply, my domain for practice E is A, 6, and 7. That's all that's in that set. All right, practice problem F asks me, what is the range for the diagram in problem D? Well, this is my domain, this is my range, so my range is P, A, and 7. Pretty straightforward, pretty simple. Okay, my last practice problem, G, asks me which of the following of these is a function. So let's look at number 1 and see what we have here. Well, we got 2 as an input, we got 1 as an input, and we got 2 as an input. If 2 shows up twice as an input, they've got to have the same output, do they? No. One has 1 and one has 2, so this is not a function. Number 2 here, 1, 1, and 2, I do have the same input for these, but I also have the same output, so yes, number 2 is a function. Number 3, once again, I have all the same input for all 3 of these and all different outputs. That is not going to work. I need to only have one output for the input. It has to be, and this is not a function. So look at the last one here. Last one, we have 2, 3, and 4, all different inputs. Doesn't matter what the outputs are. Yes, number 4 is also a function. Once again, if there's any questions, you'd like to clarify something, please feel free to contact me. Have a great day.